Our next lesson is called Representing, Naming, and Evaluating Functions, Day 1. We're actually going to split this lesson into two pieces. Today we will focus on function, not a function, and on the next lesson you will discuss the domain and range parts of this lesson. To start, please do the opening exercise, which says identify the relations below that are functions, explain your answer. So at this time, pause the video and try these problems on your own, and when you're ready to go over the responses, you can resume the video. Number 1 should be is a function. When I have to explain my answer, I would say each input has one output. So if I'm looking at this diagram above and I'm looking at the input circle, there is only one line coming off of every single input. It does not matter that there are two lines going to 1 or two lines going to 2. We are only concerned with one line coming from each element of the input. For number 2, you should have is not a function. If I have to explain myself here, I wrote the inputs of 2 and 3 have more than one output. So looking up here, if I take a look at 2, for example, there are 2 arrows coming off of that 2, which means that 2 is paired with B, and 2 is also paired with C. So if I were to write them like coordinates, you can say we have this repeated value here, which means that 2 has been matched with 2 different elements in the output, which is not okay. All right, so as I said, we're not going to discuss domain and range today, but what we are going to do now is move down to example 1, where it says for each relation, determine if it is a function and state the domain and range. We are only going to do the is it a function part, okay? So if we look at the graph here, a quick way that you can check on a graph is by using what's called the vertical line test. So we're gonna write that down here. Okay, the vertical line test. The vertical line test involves drawing or creating a vertical line on the graph to see if that line only intersects or crosses our drawn graph one time. If I draw a vertical line and it only crosses my graph one time, then it is a function. If I draw it in and it does not only cross one time, maybe crosses 2 or 3 times, then we know it is not a function. So there's 2 ways you can do this. One way is to use your pencil as your vertical line and slide it across the paper to see how many times your pencil intersects. The other option would be to actually physically draw in vertical lines in a few spots, just to demonstrate here, that you can see no matter where I draw that vertical line, it's only crossing my drawn graph one time, okay? So that tells me that this graph is a function. So it is a function. And the reason, if I had to explain, it's not asking us to do that, but these are our notes and I would like you to add this. I'm gonna put the word passes right in front of vertical line test. Now you can also use the fact that each input has one output. That excuse or explanation counts for everything, but for a graph only, you're allowed to use this special vertical line test. Okay, let's go over to our table of values. We have to decide if this is a function or not a function. So remember, we're looking for input and output. If I look at this table of values, I see a 2 here and a 2 here. 2 is going to a -1, 2 is also going to a +1. So if I were to kind of put this into a diagram, like what we saw above, I have a 2 here, and in my output, I have a -1 and a 1. And that 2 has an arrow going to both, which we know is not okay. So this is not a function. If I had to explain myself, I would say for some, inputs, there are multiple outputs. Or you could explain that exact example. An input of 2 has an output of -1 and 1, and that does not work. I also want to point out a couple other numbers that you have that are issues here. 18 goes to -3, 18 goes to +3. Here, 8 goes to -2, 8 also goes to +2. So that's why for this one I put for some inputs there are multiple outputs, because there were more than one set. But you could also just pick the one set to use as your example. All right, now we're going to move to a list of coordinates. So remember, I'm looking for each input to have one output. In this example, your x value is the same every single time. So if I'm thinking of the circle, 4 is my only input. But then my output is 0, 1, 2, 3, 4, and 5. And that 4 is going to all of these numbers, which means I have multiple arrows and lines coming off of the number 4. So that tells me an input of 4 has multiple outputs. So this is not a function. The input of 4 has multiple outputs. Or each input does not have one output. Or being specifically and saying all of the outputs 4 goes to. So you have options on how you would explain yourself here. Okay, now we're going to look at an equation. F of x equals the square root of x minus 7. Okay, so we want to think about what's allowed for these types of numbers, and you can also use your graphing calculator to help you. Okay, so on my graphing calculator, I'm going to go to the y equals screen, and I'm going to type in the square root of x minus 7. Second squared will give me the square root, and then I will type in x minus 7. If I hit zoom 6 to graph this, you can see the sketch of the graph might actually help. It is touching there at about 7, okay? Also, what will help is looking at the table. So if I go second graph, you can look at the table of values. And if you look at the table that I'm showing you here, you see that from -5 all the way up to 6, I get an error message. And then starting at x equals 7, I get my first output that makes sense, which is 0. Okay? So now that we've seen what that looks like, a couple of hints. First, a sketch of the graph may help. So we'll put a sketch may help. If I were to draw a quick sketch of this, we had 5 about here, and then 2 more past that, we had a graph that started to look like that. So if I were to draw my vertical line, you can see it would pass. But also, if we go back and look at the graphing calculator, I have scrolled down to where we can see some values, and you can see that each input only has one output by looking at the table that's created there. So it ends up taking you back to what a table of values looks like in one of our previous examples. So we are going to say this is a function because each input has one output. Okay, so now let's look at an application question. The assignment of students to physical education teachers. Okay, so our input is students. Our output is the teacher there assigned for PE, so the teachers. So for example, let's put Emma. Let's put Matt, Julia, and Evan. These are just 4 random student names. And then we'll think about our teachers for PE. We have Mr. DeWolf. We have Latini, Lasher, and Easton. So then, if I asked Emma who they have for a teacher, let's say Emma has Mr. DeWolf. If I ask Matt, Matt might say Mr. DeWolf. If I ask Julia, she says Lasher. If I ask Evan, Evan says Easton. So here's a diagram of what would happen. So what we're doing in the function, and we have to describe this differently because it's situational and words only. We are going to say we're going to take the set of students, and they are getting mapped to a PE teacher. So if you look at the diagram, each student only has one PE teacher, so it is a function. So is a function. Each student has one PE teacher. Okay, and that concludes our lesson on the first day of representing, naming, and evaluating functions, day 1.